Let's go ahead and take a look at this function. We've got f of x equals 3x squared minus 5 with its natural domain. And we're going to take a look at a couple examples here. Let's go ahead and start with part F on this one. This example is going to ask us to calculate f of 4 minus f of a. So let's go ahead and do this in stages, and let's calculate f of 4 first. All right, keep in mind the 4 is coming from one of our domain values. That's our input. We want to go ahead and put that into the function every time you see the x. So think of this in terms of substitution. This will be 3 times 4 squared minus 5. And then make sure you are completing this, taking into account the order of operations, right? You'll need to square the number first before you do your multiplication step. This will be 3 times 16 minus 5. And 3 times 16 is going to give us 48. And after we subtract the 5, that'll give us an answer here of 43. Right, so that's just replacing this first piece down here for f of 4. Still need to calculate f of a. So we'll come back up to our function, and we are going to substitute in the value of a every time we see an x. This will give us 3a squared minus 5. And there's nothing more for us to simplify here. So we'll go ahead and complete our step here. We've got 43, right? That was our value for f of a. We're subtracting everything that we got from f of a, which in this case was 3a squared minus 5. Right, you might want to put that inside parentheses so that we can subtract each of those terms. So let's go ahead and work that out. F of 4, we had 43, and for f of a, we had 3a squared minus 5. And so we want to go ahead and distribute. There's really a negative 1 here in front of that set of parentheses. Let's distribute that negative 1 through to each term. That'll give us a minus 3a squared and a positive 5. And you want to be able to combine your like terms, right? 43 and 5 are both numerical values. We can add those together to get 48. And we'll keep the minus 3a squared. So there's your final answer.